Okay, well, we begin an awesome unit in calculus. I've been told that as I cover this material, I need to make sure that I have the microphone close to my mouth, that then the sound is better. You're definitely going to want your calculator at this time. On a scale of 1 to 5, what's really interesting about this unit, scale of 1 to 5, as far as what you're going to need moving forward in calculus. This is about a 2. This is a 5. This is a 5. This is a 3, and this is a 5. Now, in terms of what you need to know for the AP exam, this is a 5. 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 They are all. We're at the heart of AP material right now. So there's, just like I just showed you, I showed you that problem that only 73% people got right, correct? Like, and we want every person to know that 3x cubed to the third is 27x to the ninth. We want everybody to know this stuff. That you want this to be second nature. This is the #1 retake test of first semester. Hopefully you can avoid that and do a great job with it. Given the function s of f of t is the distance at time t, define the following. Today what we're going to do is we're going to take derivatives and attach them to rate of change of position and velocity and things of that nature. We're going to cross over a little bit in the physics realm and hopefully make some sense of this stuff. We say that s equals f of t is what we call the position function. So if you see the variable s, generally that's referring to where something is at a given time. And I want you to think of this as like a particle moving along the x-axis. So really across the number line. So it might be at point 10, and then it might move backwards to -8, then it might move forward to say 100, but you have this particle moving back and forth. The velocity is the rate of change of a particle, and it can be moving in a positive direction, or velocity can also be negative, whereas speed is only positive, isn't it? Speed is only positive. Velocity is negative. So velocity can be positive or negative. How do we determine velocity? V of t is equal to f prime of t. The way that you come up with velocity is you simply take the derivative of the position function. Take the derivative, and that will give you the velocity. Can somebody tell me something about the velocity when the particle is at rest? Yes, the velocity is 0. Particle is rest when v of t is equal to 0. We say that the particle is moving in the positive direction when v of t is greater than 0. And we say that the particle is moving in the negative direction when v of t is less than 0. So when the velocity is positive, then it's moving to the right. When the velocity is negative, it's moving to the left. These are the definitions that we will then use to accomplish these next couple problems. A particle moves according to law of motion, s is equal to f of t for t greater than or equal to 0. What does that mean, t greater than or equal to 0? Yeah, what do you think t is referring to? Time. Does it make sense that time is going to be greater than or equal to 0? Yeah, so sometimes people worry when you have a domain restriction like that. It's just making sense that we're talking about greater than or equal to 0. We're going to graph both parts of it, but we'll only be talking about the positive portion. T is measured in seconds, and s is measured in feet. Find the velocity at time t. Before I find the velocity, I'm first going to graph this. It's a cubic. If I factor out a t, I'm left with t squared minus 12. Now I'm even going to do kind of a fancy factoring here. T times t minus the root of 12 times t plus the root of 12. You okay with that? So therefore, we know it crosses the x-axis at what spots? 0, root of 12, which is like 3.5, and negative root of 12, or negative 3.5. It says find the velocity at time t. So I want to find the velocity function. If s of t is t cubed minus 12t, can somebody tell me what v of t is? Asher, how'd you figure that out? It's the derivative of the position function, 3t squared minus 12. If I were to graph that, what shape does it make? Does it make sense to you that the derivative of a cubic function will be a parabola? So I'm going to graph that. Everybody should see that you have 3 times t squared minus 4. So therefore, it's going to cross the x and y axis at what times? Here. So I didn't take the derivative of it. I just factored out a 3. Well, why did I take the derivative of this to get that? Because velocity is the derivative of the position function. Okay. So, thank you for asking your question. So you can see it crosses at -2 and at +2. So this is what we call the velocity function, and this is what we call the position function. We have both graphs. Now we need to be able to make sense of it. True or false? The velocity of the function at time 1 is positive. False. Why? Because what's negative? Because the slope is negative. True or false? The velocity of the function at time 1 is negative. Did I not just ask the same question? Up here I said, true or false, the velocity at time 1 is positive, and you said false, correct? So you said the slope is negative. I'm saying the same thing right now. True or false, the velocity at time 1 is negative. True. This is the now this is right. I switch. That's the only part I switched, but it's the same question, isn't it? Just determining whether the velocity is positive or negative. You can't. This is the roadblock that you must cross through in order to understand. Here, when I'm talking about velocity, I'm talking about the slope, correct? So you see, is that positive or negative? When I'm talking about the velocity here, I'm talking about the location of the graph. Is my location above or below the x-axis? Below. Do you see how that matches? That the slope of the position function is negative, so therefore the location of the velocity function is below the x-axis? That's crucial that we see that piece. That has to make sense. So it says, what is the velocity after 3 seconds? How do you think I would compute that? Plug in 3, b of 3. It is 3 times 3 squared minus 12. What do you think? (27 minus 12), I get 15. We need to put a label on it. It's a rate. Feet per second. What is the particle at rest? Particles at rest whenever v of t is equal to 0. Look at your graph, v of t. When is v of t 0? V of t. When is v of t equal to 0? -2 and +2. We're only going to talk about 2 because we're not talking about negative time here. So at time is equal to 2. That's when it's at rest. When is the particle moving in the positive direction? When is the particle moving in the positive direction? That's when v of t is greater than 0. Please look at the graph v of t. What does it mean for the graph of v of t to be greater than 0? It means the graph is above the x-axis. When is v of t above the x-axis? From 2 to infinity? Everybody good with that? Okay, then we are going to answer questions E and F together. I'm actually first going to do F, and then we'll compute E. It says draw a diagram to illustrate the motion of the particle and find the total distance traveled during the first 8 seconds. So it looks like you're running out of space there. I'll put this diagram right here. And what we want to consider is we want to consider a couple things. We want to consider the start. We want to consider where it changes. And we also want to consider where it ends. So I'm going to put some time values in place. We're starting at time what? 0. When does it change direction? At what time does it change direction? Meaning it either goes from right to left or left to right. At 2. So let's look at our velocity function right here, okay? If the particle is moving left to right or right to left, okay, in this situation, the velocity is negative, so we say it's moving in which direction? To the left. And here it's moving to the right. And here is where the velocity is 0. So the particle is moving to the left, and then it stops, and then it comes back to the right. That's what's happening. So when your velocity changes from negative to positive or from positive to negative, that means it changed direction. And at 2, that happened. At what time are we ending? In this problem, it says we are ending at what time? The total distance traveled during 8 seconds. So I'm going to draw a number line. I know at what time I start. I know at what time I'm changing direction, and I know at what time I'm ending. However, here's what we don't know yet. Where am I when I start? Where am I on the number line? And what can tell me that is not the velocity function, but rather the position function. The position function is right here. That tells me where I'm actually located on the number line. So if I were to plug in 0, what would you get? So it turns out that it has a position of 0 right at the beginning. How would I figure out where it is at time 2? Plug in 2 to the position function. 2 cubed minus 24. So 8 minus 24, negative 16. So time, S is equal to negative 16. Then I'd like to figure out where it is at time 8. I plug in 8 here, 8 cubed. Some of your calculator, I think we get 512. Minus 96. 416. So its position is 416. Now we're going to put this together so it matches. Okay, I start at time 0. I have negative 16, and I have 416. Which direction do you think I head first? Do you think I head to 416 off to the right, or do you think I head to negative 16 off to the left? Yeah, you can see from our little diagram here that you know that, but you also know, according to the graph, that we are first traveling to the left, aren't we? And then we're going to travel to the right. So I travel to the left to get to negative 16, and I travel to the right to get to 416. This is the motion of the particle. That's what it does. Now that you have the motion drawn out, I want to be clear about what we're calculating at this point. Okay? So we are not looking for the displacement. We can see that the displacement is 416. We're looking for the total distance traveled. So the total distance traveled would be 16 in this direction, plus another 16 to get back to 0, plus 416 to get all the way off to the right. So that'll be a grand total of 448 feet. Yes? Good. Question. Because we are stipulating that time is going to be greater than or equal to 0 in this situation. And what I want you to do is make sure you have your calculator out as well. Make sure you have your calculator out as well. Okay? What's different about this example? It's a fraction. This is a rational function. So you can see that, you know, and in this situation, you're going to use your calculator. So there's going to be 2 problems on the back where you are basically required to use your calculator. Okay? So it says find the velocity at time t. I can't use my calculator for that. Finding the velocity, what do I do to find the velocity? Take the derivative. How do we take the derivative of that? Quotient rule. Yep, you have 4t minus 10 over t squared plus 3. Okay? So quotient rule, derivative of the top, 4 times t squared plus 3. Then what? Minus 2t times 4t minus 10. All over p squared plus 3 quantity squared. Somebody tell me something interesting about the denominator. Tell me something interesting about it. It's always what? Positive. Why? If you square something, it's going to be positive, right? If you add 3 onto it, it's going to be positive, right? The denominator will always be positive. True or false? The denominator will never be 0. True. Only if you used imaginary numbers. In this time, we're not talking about imaginary numbers because we're talking about time. So you can see that's what you get. Distribute, you get 4t squared plus 12 minus 8t squared plus 20t all over t squared plus 3 quantity squared. So when I combine like terms together, I have negative 4t squared plus 20t plus 12 over t squared plus 3 quantity squared. Everybody clear on my derivative? Okay, I'm going to write it down, and we are going to take and put some of these into our calculator. Velocity at time t, v of t is, could somebody tell me what I had again? Negative 4t squared, 20t over t squared plus 3 quantity squared. Take out that calculator. I'll show you how to make life more simple. It's joy to my day. Oh yeah. So in y1, I'm going to put my original function. I got 4t minus 10 parentheses divided by t squared plus 3. Enter your position function into y1. I'm going to enter the derivative into y2. Parentheses, negative 4t squared plus 20t plus 12 divided by, parentheses, t squared plus 3 quantity squared. And now, what I can do is use my calculator to my advantage the rest of the time. I'm going to wait for you to have that plugged in because I want to make sure you can do the operations with me. Is everybody good? I'm seeing people are still typing, so I'm pausing here. Yes? Okay, I think we're ready. What is the velocity after 3 seconds? I do v of 3, correct? I'm going to go to my table. Second table. Which entry tells me velocity, y1 or y2? y2 tells me velocity. Everybody agreed? That's where my derivative was. So I'm going to type in 3 there. And it tells me 0.25. 0.25 feet per second. Any question? What's that? You didn't square the denominator. There you go. Okay. When is the particle at rest? The particle is at rest when the velocity is equal to 0. So do I want to look at the first graph or the second graph? Second graph. So I'm going to go into y equals. I'm going to press enter to get rid of that. And what I want to focus on now is I want to focus on y sub 2. So I'm going to zoom 6, and I'm going to look at that graph. Is it tough to see where this crosses the x-axis? What could you do to try to see where it crosses the x-axis? Yeah, you find the 0, but I can't even see where it crosses, so I'm going to go ahead and zoom. All right? I'm going to take my window, and I'm going to change my y minimum to -2 and my y maximum to +2. Maybe that will give me a better picture. Maybe I can see now where it crosses the x-axis. But I still can't see very well. Can somebody give me an idea how I might even see better? Take my window and change my y min to, how about -0.5? Maybe I'll see where it crosses now. Well, I still didn't, did I? I mean, it must cross at some point, right? Now I can see it, can't I? So I want to see where it crosses the x-axis. How do I determine that point? Very good. So I'm going to use second calculate, and I'm going to choose number 2. I choose one spot where it's above the x-axis. And then I need to move over to make sure I drop below the x-axis. If I watch my y values, I just look for where they become negative. And when they become negative, I know I've dropped below the y-axis or the x-axis. And I come up with x is equal to 5.541 seconds. So you tell me, is the particle moving in the positive direction or a negative direction right here? Positive. Why? Because what's above the x-axis? What is this a graph of? The velocity. Because the velocity functions above the x-axis, we know that's moving in the positive direction. So we have from 0 to 5.541, it's moving in the positive direction. And finally, I'd like to figure out that total distance, wouldn't I? I need to consider these pieces. I need to consider when it starts, where it changes, and where it ends. And at what time does it start? 0. At what time does it change? 5.541. And at what time does it end? We're not going to have time to finish the problem, but I might have to hold you for just 30 seconds. I want to make sure we get this clear because this is where we're going to pick up tomorrow, okay? As I go into y equals and I press enter on this, and now I go into my table and I type in 0, 5.541, and 8, which one am I looking for position, y1 or y2? Y1 tells me I start at negative 0.3 or 3.33. Tells me I change at 0.361 and I end at 0.328. So we are going to pick up with doing that tomorrow. You're going to be given a little bit more time to work, and then we have to go into our rest of our application. Please try to work through problems 1 through 4. It'd be great if you get 1 through 4 done for tomorrow. Trust me, this is a get to it when I get to it assignment. You don't want to treat it like that. Good job today.